Hello everyone! Today we are going to focus on section 3.3, Proofs with Parallel Lines. We are breaking this section up into 2 days. On day number 1, we're going to talk about the converse of some of the theorems that we already talked about in section 3.2, and that includes your corresponding angles, your alternate interior angles, alternate exterior angles, and the consecutive interior angles. So today we're going to switch those P's and Q's. In your if-then statement, you have if P, then Q. Today we're going to talk about if Q, then P. So the first converse that we are going to work with is the corresponding angles converse. And it says, if two lines are cut by a transversal so the corresponding angles are congruent, then the lines are parallel. So if you recall, corresponding angles are in the same position in regards to these ones are above these lines and to the right of this transversal. And I'll call this angle 2 and angle 6. And if we say that angle 2 and angle 6 are congruent, then we can say that line J and K are parallel. So therefore, J is parallel to K. If you don't know, that means therefore. And with this converse conjecture, we are going to do an example and find the value of x that makes m parallel to n. Justify each step. So they give us two corresponding angles, and they tell us this angle measure is 7x minus 11 degrees, and this one is 4x plus 58 degrees. Well, if they're corresponding angles, that means they have to be equal to each other. So we will set 7x minus 11 equal to 4x plus 58. And that justification is corresponding angles. The next thing I'm going to do is I have to get x by itself, so I'm going to first add 11 to both sides, and that gives me 7x equals 4x plus 69, and that is our addition property of equality. And for shorthand, I'm going to call property of equality PO, property of equality. From there, again, we have to get x by itself, so we're going to subtract 4x from both sides. And what allows us to do that subtraction to both sides is our subtraction property of equality, or subtraction PO. From there, still looking to get x by itself, so we have to divide both sides by 3, which means that x equals 23, and that is our division PO. The next thing we are going to look at is constructing parallel lines, because that corresponding angles converse allows us to justify the construction of these parallel lines. I am going to try to do my best to construct this parallel line without moving the paper, because I know it gets really crazy when I move the paper. But let's read through step 1, which I already did, but it says to start by drawing point P and line M, choose a point Q anywhere on the line, and draw line QP. So I haven't drawn line QP, but essentially what that's saying is we can take our straight edge and connect point P anywhere on the given line that we have. So anywhere on line M, I can connect and draw this line or our transversal. So where it intersects, they are telling us to call this point Q, and I will be consistent with the directions so that I don't confuse you guys on this. Step 2, draw an arc with center Q that crosses line QP and line M. So we're going to take our compass, and I'm going to make this a little bit smaller here. We're going to draw an arc from Q as our center point, and I'm going to just draw this arc. It crosses over line QP and line M. It wants us to label these intersections here as point A and point B, so we can follow the directions later. I'll try and move this up a little bit for you so you can see what I'm doing a little bit better. To continue on with step 2, using the same compass settings, so I have not changed the distance between my pointer and my pencil at all. Draw an arc with center P and label point C. And point C is going to be where we cross line PQ. So putting the pointer of my compass on P, we're going to make an arc, and this arc is going to cross over line QP. But I'm also going to draw it a little bit further down. This is personally what I like to do, so that it looks like it's going to cross what would be the parallel line, because I'm going to need an intersection point here in a little bit. So make that arc a little larger than you think you have to. Step 3, draw an arc with radius AB and center A. So I have to take my compass and expand it or contract it so that we have this radius. So the tip of my compass and the pencil are the distance from the center point of A to the center point of B, and that's going to be our radius. So that's the radius it's talking about right there. So draw an arc with radius AB and center A. So I am going to now take the point of my compass, put it on A, and I'm going to draw that arc, and it should cross over B if I did my radius correctly. And then, using the same compass setting, draw an arc with center C. Oh, I forgot to label C. We need C up here. So we're going to put our compass at this point here and cross over the arc. We're going to intersect that arc that we drew, and they want us to label that point D. So label this point D. And now, using a straight edge, draw a line PD. This line is the parallel to line M. So if we did this right, which you'll be able to tell by looking at it, if we did this correctly, we should be parallel to the given line. And there we go. Now, if you didn't do it correct and it looks like it's extremely off, more than a degree or two, that's what I tell my students. If I can tell that visually that it's off, it's off. Erase everything and do it again. There's always a way to correct it on an assessment, just by looking at it. Now let's get into the last 3 converses. So the first one we'll talk about is the alternate interior angles converse. If 2 lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So if I just pick a pair of alternate interior angles, if I pick these 2 angles here, I call it angle 4 and angle 5. If we can prove that these are congruent, then we can say that J is parallel to K. Put that little therefore sign there again. Moving on to the alternate exterior angles converse. That says if 2 lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So if we take a look at angle 1 here and angle 8, those are our alternate exterior angles, and if we can say that those are congruent, then we can say that line J is parallel to line K. The last converse we have to talk about is the consecutive interior angles converse. So the consecutive interior angles converse says, if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So if I take a look at angle 3 and angle 5, if angle 3 and angle 5 are supplementary, then J is parallel to K. Oh, totally wrote that off of the screen. Sorry about that. So if angle 3 and angle 5 are supplementary, then J is parallel to K. The last thing we are going to talk about in this section is an example that relates these last set of converse conjectures. So the example I have here is find the value of x that makes m parallel to n. We don't have to justify this, we just have to do the algebra. So what it looks like is they give us 72 degrees and they give us a 4 times x plus 5. These angles, we don't have a theorem that relates them. So what we could do is, knowing that we have, if we're trying to prove them parallel, then we can say that 4x plus 5, 4 times x plus 5, has to be the angle measure of this angle up here because of alternate exterior angles. And these two angles are adjacent to each other, which means they're a linear pair. If they're a linear pair, then they are supplementary. We can then say that 4 times x plus 5 degrees plus 72 degrees equals 180 degrees. So let's distribute this 4 through the parentheses. We end up with 4x plus 20 plus 72 equals 180. Combine our like terms. We will have 4x plus 92 equals 180. Subtract the 92 from both sides, and we end up with 4x equals 88. Divide everything by 4, and we finally get x equals 22. So that concludes the first half of talking about the converse of angles. And tomorrow, or day 2 of this lesson, will take us into the proof-like thinking of proving these converses and why they're true. So thank you very much for listening, and I will talk to you tomorrow.